It's my pleasure today to introduce Dave McNitt, who's going to be talking about bobcats today, bobcat spatial ecology for his master's thesis. Dave came to us from Maryland originally, but went to Paul Smith's College in New York. But I met him when in 2013, graduated in 2014, but I met him in 2013 when he came down as a technician for my Belize Jaguar project. So 2013 and 2014, he got grants both years to come down and work on the project, on side projects, and did such a good job. He's excellent in the field. Really, it was clear to me that he was like, this guy, got my eye on him, got a grad school material. But also, the second day in the field house, he made this awesome mango salsa. From like local stuff in the village, like just found some mangoes, got some tomatoes. I was like, oh, really gotta have one now. So he stood out for that reason as well. Then we were trying to get funding for him to bring him in to do more work in Belize. That fell through, but at the same time, the Bobcat funding did not fall through, so it actually became a reality. And so we switched Dave from jaguars to bobcats. Sorry, it's a smaller cat, but still a cat. And he has done a great job the last 2 years in Bath County, Virginia, collaring bobcats and learning something about their spatial ecology, which he's going to talk to you about that right now. So, Dave, I'm going to let you take it away and talk about.
I think jaguars are pretty cool, but I think bobcats are cooler because they're here all around us. They're not down there. So first of all, thanks for coming out. This is a much better turnout than I expected, considering the time of year, and I know a lot of people change their schedules to be here, so I really appreciate that. I'm going to dive right into things because we've got a lot to cover. Today I'll be talking about my thesis research on the spatial ecology of bobcats in Western Virginia. And I'm going to start the talk out with some background information and some context here and some history. And then I'll get into the specific research I've been conducting. So my master's research has been part of the broader Virginia Appalachian Carnivore study. And right now that consists of me and PhD student Robert Alonzo. We're collaborating. And the goal of the study is to examine the ecology of bobcats, black bears, and coyotes, specifically as it relates to white-tailed deer consumption. But my goal in this study has really been to focus in on bobcats. I'll explain why here momentarily. So I think it's really important to consider the broader history and the context of Appalachian ecosystems anytime we're talking about them, because it's a really dynamic system. It's been altered significantly, and it continues to change. I think that should inform our research, how we conduct it and interpret it, and it should inform our wildlife management decisions and what we strive for. So at the time of European arrival, this was the large mammal community of Western Virginia, where we are right now. In addition to bobcats and bears and deer, we had wolves, mountain lions, and importantly, we had large-bodied grazers, namely elk and bison. And in the centuries since European colonization, especially during the 1800s and around the Industrial Revolution, there was pretty much natural resource extraction was being conducted at an unsustainable pace around this time. You had unregulated timber harvest for industrial furnaces, home heating, and lumber, and it was just completely unregulated. And concurrent with that, there was a lack of any wildlife management or regulations on wildlife take to speak of. So that brings us to the early 1900s, and at that time, things were in a pretty bad state. Our largest mammals had pretty much been extirpated from the landscape, the largest carnivores and the elk and the bison. And all wildlife populations were very low around this time. Bears and bobcats especially were very low. Only the most remote areas of the mountains and game species we consider common now were at low numbers around that time. And I think it's really important to remember this is not ancient history I'm talking about. This isn't fossil records. This is, the last wolf was killed in Virginia, I believe in the early 1900s, around 1911. So this is only a couple generations ago. So, and then, wildlife and land management began in earnest in our country around this time in the early 1900s through the creation of agencies to create and enforce regulations and actively manage wildlife populations. Forests began to regenerate and wildlife populations recover. Now, the recovery of carnivores took longer generally because there weren't as many concerted efforts to restore them as there were with deer and turkeys with restocking efforts and the like. But in recent decades, we have seen recovery based off harvest metrics, which are not a direct measure of population abundance, but they give us an idea. Here we have bobcat harvest going back to the late 70s. You can see that has steadily increased, especially in recent decades. We see a similar trend with the black bear harvest going back to 1970, upward trend, especially in recent years. And then lastly, coyotes established a breeding population in Virginia around the 1980s, one of the last area in the contiguous United States to be colonized by coyotes. And based on hunter surveys looking at harvests and observations, we see an increase there as well, going back to the 1990s. So this brings us to our present day kind of larger mammal predator-prey community. And it consists of bears, coyotes, bobcats, and white-tailed deer. Now it's important to understand the role of these carnivores as they're back on the landscape and gaining a foothold back, repopulating areas. And we've had research on bears and coyotes. Virginia Department of Game and Inland Fisheries, VDGIF, has funded research on coyotes and bears in Western Virginia with these studies that were both conducted by the Virginia Tech Department of Fish and Wildlife. But there hasn't been a comprehensive study on bobcats like this. And there's really a lack of information on bobcats, not just in Virginia, but in the broader central Appalachian region that includes West Virginia, Western North Carolina, Tennessee, Kentucky, this kind of central Appalachian mountains. So the information that we do have, this local information, comes from scat analysis conducted on the recent coyote study. We were able to get some valuable information from that. They estimated bobcats at around 9 bobcats per 100 square kilometers. That's about twice the population density estimates of coyotes in the same site. And using morphological along with genetic scat analysis, they determined the most common diet items in order of frequency of occurrence to be squirrels, then smaller rodents, deer, and cottontail rabbits. These are kind of a rough approximation of the ranking because diet items are digested and consumed in different ways, and they show up on the landscape in different ways. But this information is incredibly valuable to us to have this information. However, what we're lacking is any type of space use information for bobcats in Western Virginia and the broader region. So that's where I kind of came into focus on bobcats. So bobcats have been studied quite heavily throughout their distribution. So we'll take a step back and just look at bobcat ecology, what we do know about bobcats. So bobcats, they're mid-sized felid, and their distribution ranges from central Mexico to southern Canada and across the contiguous United States. Bobcats are ambush predators, and one thing that has been found across their distribution, a lot of things vary due to the wide variety of habitats that they live in, but they select for dense cover because they need to ambush and stalk prey. And in that same vein, bobcats, like all cats, are obligate carnivores, so they need to eat meat to survive. So they either need to be acquiring prey or scavenging. So bobcats select for dense habitat and abundant prey. And the importance of this is evident in their distribution. The area where you could say they're doing the worst is the agricultural Midwest, where you have these row crop monocultures, heavily fragmented habitat, and that's where we see them doing the worst right now. So that sheds some light on what's really important to their populations. So zooming in a little bit more, this is a conceptual model looking at the factors driving bobcat space use. I already covered resources on the left, the cover, dense cover, abundant prey, but interactions are important to consider too, both inter and intraspecific interactions. So especially intraspecific interactions, because bobcats have a few things about their behavior that are important to consider. Bobcats are solitary and territorial. So each bobcat has a distinct home range that they live in, and at least part of that they're going to be territorial over. Bobcats are also polygynous, meaning that males will breed multiple females. So males seek as large a territory as possible, as large a home range as possible, to overlap as many female home ranges as possible to maximize breeding opportunities. Conversely, females only seek as much space as they need to acquire prey for themselves and their young. So the way this shows up in their space use is that male home ranges are generally much larger than female home ranges. They generally use much more space. Another important consideration is that females have to raise their young alone with no help from a mate. So they're under tremendous pressure when they're raising their young to acquire sufficient prey to support both themselves and their young. And these factors all change seasonally, especially here in these temperate latitudes. I'll touch more on that in my methods section. Once again, as I mentioned, bobcats have been studied in a lot of areas, but not much in this region here. Their home range size can vary a lot, and this is largely thought to be based on prey availability, and that if they have to travel further to get prey, they're going to use more space. So in further north latitudes, we see larger space use of bobcats. So So here on the East Coast, looking at Western Virginia and the central Appalachian area, a lot of folks would consider this to be more the southeast. But these are the highest elevations in the eastern United States in this region, especially a little further south of here, but here as well. So a lot of conditions are more similar to northern climates. So with this kind of unknown factor here, we don't really know where their space use fits into this trend. So this brings us to my objectives, considering everything that I just described. My first objective was just to get some solid home range estimates for bobcats in this region and in Western Virginia specifically. Compare to these other regions and see where we fit into things and see how wide the sexual dimorphism actually is. And then more specifically, my goal was to see how their space use changes throughout the year. This is important both to understand the ecology of bobcats and their local ecology, but as I mentioned, we're interested in consumption of deer, and this is important in informing further research into those facets as well. And then lastly, I wanted to look at some of the forest management practices being used in the Appalachian region and see how they influence bobcat space use. So this is our study area. It's the western half of Bath County, Virginia. Bath County, Virginia is a couple hours drive north here of Blacksburg, where we are right now. And Bath County in some ways really exemplifies the land cover trends you'll see in Appalachia. It's almost 90% forest. Over 50% of the county is public land, most of which is national forest. So public land management practices are highly relevant to wildlife in this area. And elevations reach over 4,000 feet in areas, which goes back to my previous point regarding the climate conditions of these regions. So we've divided our capture efforts within 3 sites within this broader study area to capture the whole gradient of habitat management and land use practices in the region. To the west side of the study area, we have Gathright Wildlife Management Area. It's a state wildlife management area. There's timber harvest conducted there, but there's no prescribed fire in use, nor has there been. To the north, we have Back Creek Mountain and Hidden Valley Recreation Area. This is national forest, so you have both prescribed fire and timber harvest. And then to the east, you have Warm Springs Preserve, which is Nature Conservancy land. They use a lot of fire. And on adjacent Forest Service lands, you have fire and timber harvest. And then within both of these, there is private land intermingled within these study areas. And of course, they're bobcats, so they range in and out, but we wanted to divide our capture efforts across this broader area. So of course, if we're studying the space use of bobcats, the first thing we need to do is figure out where they're spending their time. Where are they? We do this using GPS telemetry by collaring bobcats. I captured the bobcats in cage traps mostly during 2017 and 2018. My capture efforts were primarily focused from January through April. Once I captured bobcats, I anesthetized them and fixed them with GPS collars programmed with a 4-hour fixed interval. Each year I captured 7 males and 3 females for a total of 14 males and 6 females. So you see that overall it's not a huge sample size, but for bobcats it's actually relatively a larger sample size. But unfortunately a smaller sample size of females, and in 2017 we didn't have great fixed success in some of our GPS collars. It was moderate to poor in some. This will influence some of the analysis methods that I use later, so just keep that in mind. So getting into those methods, as I mentioned, the first goal was to get reliable home range estimates. So for this, I used the autocorrelated kernel density estimator. In short, this home range estimator uses the density of relocations and the movement characteristics of each animal to create their probability, to estimate a probability of occurrence on the landscape. And then we take a 95% isopleth of that probability distribution to exclude extraterritorial forays. Also, this home range estimator can correct for irregular sampling schedules and for some missing data by using a weighting method. So this was really valuable for our data set and some of this poor fixed success in our first year. I also estimated 95% minimum convex polygons, a more traditional estimator that's not as robust, but I use this to compare to these other regional estimates that were all from previous studies using 95% MCPs. So here we have the home range estimates for all of our bobcats. On the left side are the bobcats captured in 2017, monitored through 2018. And on the right, we have bobcats captured in 2018, monitored through 2019. And the male home ranges are denoted in cooler colors. The female home range is denoted with warmer colors. And get my pointer here. You can see the female home ranges are quite a bit smaller than the male home ranges, and this is what our size estimates reflected. That male home ranges are nearly 3 times larger than female home ranges in Western Virginia, or at least in Bath County. And I also want you to note these two, really big home ranges here. This dark blue one and this turquoise one here. These correspond to 2 dispersing bobcats that I captured, and that's going to inform some of our further analysis, so keep those in mind as well. Those were 2 young male bobcats that once we monitored them, we noticed that they were not residents. Looking at the regional comparisons, this is with MCP, so the numbers vary a little bit, but one thing you can see is that we're not seeing space use nearly as large as these far northern latitudes. I think this is because even though we have some conditions that mimic climate found further north, we don't have a sustained snowpack with deep snow throughout the winter. Bobcats are not well adapted to deep snow. That's been found in several studies. So I think that's a big contributing factor there. But as I didn't mention it. Also in the further northern latitudes, you can see seasonal changes sometimes where home ranges will expand in winter and contract in summertime. So that was another thing we were interested in looking at. So I broke the year into 3 seasons based on the biology of bobcats, and I used these seasons for all of my seasonal analysis. So just keep this in mind as I go through this presentation. I'm using the terminology seasonal areas of use here. This is a splitting of hairs terminology-wise. I'm going to use the terminology seasonal home ranges. So if you see SAU, I'm referring to seasonal home range. So the first season is the breeding season. In temperate latitudes, the peak of bobcat estrus occurs in February and early March. So this is when they're going to be breeding. Gestation period is about 60 days. So they're giving birth in April, May, and then the kittens are heavily reliant on their mother for up to 4 months. They'll be consuming milk, and even once they're done consuming milk, she'll be bringing them prey. And as I mentioned, she's raising them alone. Now for males, they're not helping at all this time of year. So for them, this is basically summertime. You've got fawns on the ground. It's the growing season, so we can think of it like that for males. Dispersal season, you have young of the year starting to leave their mother, and they'll spend some time in the area, but they're going to strike off on their own some. And the bobcats born the previous year are really going to be attempting to stake out their own home range prior to the breeding season because they're going to reach sexual maturity fully at their 2nd year. So as I mentioned, we wanted to see if there were seasonal changes here. So I estimated home ranges for each season, and I created a linear mixed effects model with the response being seasonal home range size and the predictors being sex and season, both the main effects and interaction. And I included random intercepts for individual animals. So looking at the results from that model, I didn't find any evidence for seasonal changes in home range size throughout the year. Male seasonal home ranges are about 3 times larger than female home ranges across all the seasons. So we're seeing that throughout the year they're using more space than the females. Once again, this shows we differ from conditions found in the far north because we don't see big contractions expansions in wintertime and so forth. Another interesting note is that the average size of the seasonal home ranges is very similar to the size of annual home ranges. So that shows that they're not using entirely disjunct areas, because if they were moving to completely different areas and had separate seasonal home ranges, their annual home range would be quite a bit larger, but they're very similar in size. Looking at the seasonal home ranges for some of the bobcats shed some more light on their space use throughout the year. So on the left, we have seasonal home ranges for 2 females, on the right for 2 males. And all of their seasonal home ranges are overlaid here. So the red denotes the breeding home range, the blue denotes denning, and the green denotes the dispersal home range. And one thing you see first off just looking, and if you look at all the cats, you'll notice it as well, is that they don't use completely different areas throughout the year. And that's not really a surprise, considering the ecology of bobcats. But we do see some seasonal shifts in shape, sometimes more so than others. And I think this is driven by varying resource selection across seasons, which I'll get into in a little bit. But we did find evidence for that. So I think that's what these subtle shifts reflect. I think that seasonal shifts, anything wide, is restricted by territorial neighbors. Because if you're a male, you have other males neighboring, and they're going to be competitive about their territories. And for example, some evidence for that is this shift here, where M21 shifted during the breeding season. The neighboring male bobcat was hit by a truck, and that shift happened almost immediately following that home range vacancy. That's when we detected that shift. And we saw that in multiple occasions, so that's interesting. Looking at movement rates, I simply calculated movement rates by the straight line distance between points divided by, between successive points divided by the time interval that had elapsed, reported in meters per hour. This figure here on the bottom right shows the step length distribution for bobcats. That's for a 4-hour step length. Sorry, 4-hour time interval. And then I modeled this similar to the home range size, except using a generalized linear mixed effects model with a gamma distribution. The response being movement rate. Once again, the predictors, sex and season, both the main effects and their interaction. And we did find some seasonal changes in movement rates. So first of all, across the board, we saw that male movement rates are about 1.5 times higher than those of females. Looking at the seasons for each sex, I found that female movement rates increased during the denning season. And I think this is likely due to increased movements between denning and foraging sites. As I mentioned, females are under a lot of pressure during this time. They basically have to double down on foraging to support themselves and their young, to produce milk or bring prey to their young. But at the same time, they have to be spending time in the den, lactating, protecting their young, moving them between auxiliary den sites. So this results in increased movements between these two sites, and other studies have found a similar effect. I also found that male movement rates increased during the dispersal season. Spatial organization of bobcats is generally in flux during this time. As I mentioned before, you have these dispersing bobcats. So any dispersing bobcats are going to be seeking out a home range during this time, but also resident males are probably ramping up their territorial marking and patrolling during this time, and I attribute this increase in movement rates to that. They've got these big home ranges, and they're patrolling them and marking them because they have dispersing bobcats on the landscape, and they're also getting ready for breeding season. So the next question is, what habitat are bobcats selecting for? And I examined this question at two scales, the broader of which is second order selection. And second order selection is the selection of a home range within a landscape. So I did this by creating randomly located home ranges, which are basically circles around each actual seasonal home range. And I created 10 of these for each real seasonal home range. Now I constrained these simulated home ranges within a distance, 5.3 kilometers of the center of the actual home range. And I based this radius on the space use I observed of those dispersing bobcats that I mentioned earlier. I think this is a more accurate depiction of what's available to a bobcat than arbitrarily delineating a study area, something way on the other side of the county, versus what we actually saw bobcats, where we actually saw them dispersing before selecting a home range. So I sampled all the land cover variables in the randomly created home ranges and within the actual home ranges, and then I basically used logistic regression to compare them with a generalized linear mixed effects model. The response being whether a sampled cell was within the actual or simulated home range. My predictors were distance to deciduous forest, distance to mixed forest, and distance to field. That was all derived from the National Land Cover Database. And then elevation and slope were my topographical variables. I had a season interaction with all these predictors, and I ran separate models for each sex. I only included resident bobcats in this analysis also. I did not include the dispersers. So looking at our results for females, female selection of home ranges on the landscape. Oh, also I ranked the predictors by the size of their coefficient estimates. So that gives us an understanding of what are the most important predictors. And for females, the strongest predictor was elevation. Across all seasons, females selected home ranges at higher elevations than expected at random. Distance to deciduous forest was the next strongest predictor for females. Females select home ranges closer or more within forest than expected at random during all seasons. Next was distance to field. Females select home ranges further from fields than expected at random during all seasons, and this effect is strongest during the denning season. I observed seasonal changes in selection for mixed forest and slope as well, but these were the weakest predictors. And for the sake of time, I don't really have time to go into my interpretation of those findings, but I'd be happy to talk about them more after the talk. So I think it's important to let's just take a look at the home ranges. We don't have a huge sample size, so we can just look at the home ranges and see what's going on here. And I think it kind of helps us interpret what we're looking at here. So the take-home message from the findings is that female home ranges are more likely to be at higher elevations in forested areas and further from fields than expected at random. Some of these females we captured on field edges in the valley bottom, and they proceeded to range almost entirely into the forest. Interestingly, this female did overlap some fields, and these fields are on public lands, on national forest. So could be some kind of risk aversion, but it's hard to say. Another important take-home message, there's evidence for seasonal changes in resource selection. So thinking back to those slight shifts in shape that we saw, you could see how during the denning season, a female's denning seasonal home range might shift perhaps into the forest more, or maybe in wintertime, a female's home range could shift slightly to engulf some of this mixed forest here. Looking at male second order selection or selection of home ranges on the landscape, elevation and distance to fields were by far the strongest predictors for male second order selection. Males select distance to field is the strongest. Males selected home ranges closer to fields than expected during all seasons. This effect was stronger during the denning season. Similar to females, we see that males select home ranges at higher elevations than expected at random during all seasons. This effect was slightly less so during the breeding season. So these were by far the two strongest predictors. And then for distance to deciduous forests, we see some differential selection. We actually see avoidance of deciduous forest during the breeding and denning season, but during the dispersal season, we see some selection. And that's interesting based off some of our other findings. We saw differential selection for mixed forests too. Let's once again go to the home ranges and look at them to kind of interpret this. So this kind of comes back to what I was saying earlier. Males are going to be seeking to maximize breeding opportunities on the landscape. And this is really going to drive their second order selection to a pretty large degree. So what we see is that male home ranges are larger, and it seems like they certainly have a higher likelihood of encompassing fields. Now, fields are not highly available on the landscape, so it doesn't take much of engulfing a field to show very high selection for it. So what we're seeing is in many cases, males using multiple ridgelines. We're seeing selection for higher elevations for both sexes. If we've got female home ranges more exclusively on the ridgelines in the forest, it would make sense that a male would want to cover as many of these home ranges as possible, and that potentially might mean crossing multiple ridgelines to encompass as many females as possible. So this is where we need to look at resource selection at multiple scales, because this really informs what we're looking at, because just looking at the home range, as I mentioned, could be confounded by other factors, or it might not tease out everything that's going on. So the next scale I looked at is third order resource selection, or the selection of locations within a home range. You can see here that locations aren't evenly distributed within a home range. They clearly select some areas over others. It's a clumpy distribution. It's important to remember that the other scale informs what we see at this scale. Like if you had a home range that was almost completely in forest, but there were some other land cover types, and you saw on the third scale avoidance of forest, you might say, oh, bobcats are avoiding forest. But you never looked at the other scale where you saw that, like for females, for example, they're selecting their home range within forest. So you need to consider both scales. So I use a very similar method to the second order resource selection, but instead of randomly simulating home ranges, now we're randomly simulating locations. So within each seasonal area of use, I randomly simulated 10 locations for every true location. And similar to the other analysis, I sampled the land cover variables at the real and simulated points. That's the response variable, whether a point is real or simulated. I use the same land cover variables so we can compare across scales. As I mentioned, that's very important. Now, unfortunately, I was only able to run a sex-specific model for males here, because as I mentioned, we had some poor fix success in 2017. You can't include collars with poor fix success in third order analysis, because at this finer scale, if the reason those collars aren't getting a fix is due to dense canopy cover or topography, then you could have a bias, and you're not detecting what the animal's doing, you're detecting where the GPS collar works best. So unfortunately, that brought the sample size of females down to like 3 once I parsed out the ones with poor fix success. Only able to look at third order for males. We will include females in some third order analysis. I'll combine the sexes later on. So looking at male third order selection, once again, elevation it's the strongest predictor in this case. It's been strong across all the scales we've looked at so far. All seasons, males select locations at higher elevations than would be expected at random. And actually, During the breeding season, they're at relatively lower elevations, still higher than expected at random, but lower than the other seasons. We see a similar pattern with slope where they select for gentle slopes during the dispersal and denning season, but during the breeding season, they're on steeper slopes, which is not something you expect to see in wildlife generally. It's costly to move on steep slopes. The prey has a cost of moving on steep slopes generally. And this is something that hasn't gotten a lot of attention in the bobcat literature, but I think this is related to mate searching behavior because there is a lot of literature on the cost of searching for mates when you're a solitary, wide-ranging animal. And for males, they need to search for multiple mates on this rugged landscape. And my interpretation of this is that they're in these rugged hollows and coves along the mountainsides because we see they're at lower elevation. They're not at the ridge tops, but they're not in the valley bottoms. It's higher than expected at random. They're on steeper slopes. This suggests they might be moving off the ridge tops and searching, maybe vocalizing or scent marking in these hollows and drainages. So now we look at third order selection and we see that all seasons males are selecting for deciduous forest. So that sheds some light on, we saw avoidance on the second scale, but I think there are other factors driving that, as I mentioned. As far as where they actually spend their time on the ground, they're selecting for deciduous forest. Now, interesting to consider is that is we also see selection for field, closer to fields than would be expected at random. This effect is stronger during the summer season. As I mentioned, this is more not related to denning, but fawns being on the ground and things of that nature. In a distance-based analysis, when you see selection closer to adjacent cover types than expected at random, this can indicate use of an edge because they're in one cover type, so the distance is 0, right? And they're immediately adjacent to another one. So those are lower distances than expected as well. So I think this is probably selection for forest edge along fields. Get those edge effects in there. And this is kind of where I want to shift gears a little bit. We're going to look a little more closely at what's going on the ground, what's relevant to bobcats. This is what we need to think about. They're selecting for deciduous forest. Well, deciduous forest makes up 90% of the study area. So that doesn't necessarily tell us a ton. We need to think about what's relevant to bobcats. When you're this high off the ground, you're not thinking about the canopy so much, perhaps. So this comes back to the history I talked about earlier, and we need to think about this in the context of bobcats' adaptations and the conditions in which they evolved. So this goes back to what I was saying about the fact that the forests were entirely deforested about 100 years ago and they regenerated from that state. So before that, we have a lot of evidence now that the forests were different. They were probably a diverse mosaic, some of which may have been oak savannas like this, where you have fire creating openings, other disturbance, and then you had these grazers, these large-bodied grazers, maintaining these openings and grazing and having complex interrelationships there. And then fire returning frequently, which is important because recent soil core and tree ring analysis shows that fire returned to Appalachia every 3 to 12 years. So fire was widespread and it was frequent. Well, these forests regenerated without fire. They also regenerated without grazers. When we cut down all the trees, the soils were heavily eroded. There were unnatural fires that destroyed the soil even worse. And then as they regenerated, we had a myriad of invasive pests and diseases like chestnut blight and emerald ash borer, which further altered the forest communities. So this is what the forests look like now. They're homogeneous, they're even-aged and densely stocked. They have a closed canopy and an unproductive bare understory. And the tree species within them have been altered too. They're increasingly mesic species that don't produce mast versus oaks and hickories, and of course, the chestnuts are gone. Mature ones at least. So luckily, researchers and managers are starting to understand these problems and actually address them. And that's mainly through recreating these natural disturbance regimes through fire and timber harvest, and even mowing can recreate grazing to an extent. For example, you have multi-agency collaborations like the Fire Learning Network, the Nature Conservancy, the Forest Service, other state, local agencies, and federal agencies. They're working to combine their resources and put fire on the ground. But these efforts are still limited by logistical constraints, and fire is proportionally small and it's patchy on the landscape. However, fire has increased. Prescribed fire has increased in use annually since the late 90s. Every year it's increased in use on the George Washington and Jefferson National Forests, which are the national forests that we're in here. So that leads to the question. This is obviously relevant to bobcats based off what I described about their ecology earlier. So the question is, how are they using these closed canopy forests? Well, my prediction is they're using the areas that aren't closed canopy forests. More specifically, I'm interested in delineating between the tools that are available to managers so we can better understand their impacts. So I predicted that bobcats would select for areas near forest edge, where forest meets field and you have edge effects and light penetrating into the forest floor. Areas that have been burned, specifically where the canopy has been opened up by fire, and areas of timber harvest. So I examined this through third order analysis, resource selection analysis, using methods very similar to the model that I described previously, selection of locations within a home range. I characterized forest edge along fields using land cover data, simply where forest cover type meets fields. The fire data came from a collaborative data set created by the Nature Conservancy and the Forest Service. They did an analysis where they went into post-burn aerial imagery and they classified all the areas that had 50% canopy cover or less. And they had a couple different classes, but I combined it all into areas with 50% canopy cover or less resulting from fire. And then timber harvest data from U.S. Forest Service, VDGIF, all timber harvest going back the last 15 years. And then I created a forest interior covariate, which is basically just contiguous forest 300 meters or more from another cover type or from these canopy openings to model these areas of closed canopy forest. So I combined sexes for this model, all the bobcats that had high fixed success from 2018. So that's 7 males and 3 females. I had to use high fixed success for this, especially because I'm looking at canopy cover. So I can't have canopy negatively affecting GPS fixed success. So anyways, I run this model and I find selection for all these canopy openings and avoidance of the forest interior. Now I found especially strong selection for areas of fire-created canopy openings and forest field edge. I did find selection for locations closer to timber harvest than expected at random, but we had a relatively small sample of bobcats covering a relatively small sample of timber harvest. And unfortunately, there's a wide array of harvest prescriptions and stand ages. You have shelterwood cuts, clear cuts, gap cuts, cuts that are 1 or 2 years old and might be wide open, or 15 years old and pretty regenerated at this point. And probably that variation confounded our results a little bit. But it's clear that we did find strong avoidance of forest interior. So here's the same land cover map of the study area, but with these variables mapped on it. The orange denotes fire-created canopy openings, the purple denotes timber harvest, and these hatched areas denote forest interior. And the point I just want to make here is that when you look at these fire-created canopy openings, you can see the landscape level impact that they have. Now, timber harvest is important in restoring the historic forest structure. To go in there and mechanically thin out the forest, maybe remove undesirable species, or create conditions that will allow fire to work the way it should. But you can go in and set a whole mountainside on fire in the span of a couple days if you can get the boots on the ground. And you can benefit the fire-adapted tree species and get them out. You can open up the canopy to benefit wildlife species by creating habitat. For example, this past spring in our study site, the Forest Service did a 3,000 acre plus 3,000 acres helicopter ignited burn, set the whole mountainside on fire. They were able to do that in the span of 2 days. So these are both important, but it's clear that fire can have a landscape level impact. And it's no surprise to see bobcats, a native wildlife species, selecting for it, because all the native wildlife, whether they be plant species or animal species, they evolved with a 3 to 12 year fire interval. So just to recap some of my findings and kind of go over the take-home messages, I think one important finding is that we saw pretty wide sexual dimorphism in space use. Males are using much larger home ranges and they have higher movement rates as well. We saw a seasonal effect on movement rates, but not on home range size. So we're seeing that bobcats are using their home ranges more intensively at certain times of year, but not actually expanding or contracting their ranges. We found some evidence that territoriality and land tenure are influencing the spatial organization of bobcats. That's no surprise, but it's interesting to see this land tenure thing where when a vacancy appears on the landscape, it does get filled by neighboring bobcats. Recapping the findings on resource selection. At our broader scale, I think one important take-home message, we're seeing this at both scales really, is that bobcats are selecting for higher elevations. Especially females are placing their home ranges more on the forested ridge lines, and this effect is more pronounced during the denning season. Male home range is more likely to encompass fields, especially during summer months. Looking at third order selection, we said within home ranges, bobcats select for these areas of open canopy structure, especially those created by fire and along field edges. And we see that males exhibit the strongest third order selection locations within the home range for fields during summer months. So what is the point of all this information I just threw at you guys? Well, there's a few things I think, and I think that we're going to continue to learn more, and I'll explain why in a little bit. But I think that the sexual dimorphism that we've seen alone has implications. Now, one would think that males would have higher mortality risk due to greater space use, greater probability of encountering risk threats on the landscape. Now, Mike Fees has told me that harvest data doesn't indicate this. The ratio is actually more even of hunted and trapped bobcats. But I would wonder about looking at roadkill mortalities or other potential causes of mortality and what the sex ratio might be for that. I would also wonder about what the sex ratio of adult resident bobcats on the landscape is, looking at the space use difference between males and females and considering their territoriality. On our study, we saw a 43% mortality rate overall in males and a 17% rate in females. One female died. She died of natural causes. She was really old. She was over 6 years old. We had males getting shot, trapped, hit by a car, things like that. So I don't know. That involves some more examination, I think. But we almost certainly have differences in detection probability. Males are using more space. They're moving more. They should be more detectable in the landscape across a greater area. Further, detection probability could change seasonally for either sex. So if you're doing non-invasive research like the scat analysis I mentioned earlier, I think it's really important to consider these sex and seasonal differences in detectability. If you're looking at diet data, for example, and you're not accounting for sex, you might have a male-skewed data set where you're looking more at males, or you might have higher detectability of females in the summertime versus the wintertime. So I think it's important to incorporate that into models. We've seen the importance of forested ridges for both sexes. And I don't think this is highly relevant now because we're very fortunate that a lot of these ridgelines are public lands in Appalachia, whether it be North Carolina, West Virginia, here. A lot of them are forested ridgelines, but I think we should take this information and put it in our pocket. And considering future development or future land use decisions on these ridgelines, I think we want to be armed with this information because the importance of these mountains for bobcats is important. Even when numbers were low, they were still here. They were extirpated from the non-mountainous areas. But I think this selection for canopy openings and for field edge what we see here, I think these are the findings I really want to highlight because this comes back to the whole point of the study, which is to look at deer consumption. This is not purely a bobcat ecology study. So as I mentioned, Robert is digging deeper into the questions relating to deer consumption. And Mike Cherry has a graduate student up in Bath County who's collaring deer, and they're looking at mortality of deer from that angle, especially fawns. So I hope that these findings can inform that future research. One thing is the summer selection of field edge by males at both scales. So this is the time of year that fawns are on the ground, and this selection for fields during this time bobcats are known fawn predators in many areas, and they can prey on fawns for a longer period of time than some other carnivores will. So this selection for open canopy and the selection for field edges and fields during the summer months, this will be useful information for Robert and Garrett when they see where predation is occurring to maybe tie back and connect some of the dots regarding these patterns that we're seeing. And then in general, we're seeing bobcats select for canopy openings. So bobcats, they're a game species themselves, a fur bearer species, so we should be interested in their own population management, but also they're a predator, so they can influence other game species. Their prey can be deer, rabbits, as I mentioned, ground nesting birds. So if you have a bobcat home range incorporating a ridgeline, and within that home range you have only a couple small canopy openings, maybe food plots put in by managers, and you have your prey focused in those areas, well, I know as a hunter myself, those food plots are where I would go hunt, and I think the bobcat probably knows that too. Now, on the other hand, if you had one of these whole ridge lines lit up with fire, like I showed in those other figures, some timber harvest mixed in too, within that bobcat's home range, you're boosting the prey overall, and you're spreading the prey out. Now, potentially, this could have a sort of predator swamping effect where your predation rates are going to be lower overall. Because bobcats are territorial, you're going to be limited in how many bobcats are going to occur within any one area due to that. And then lastly, I just want to say that, bobcats are the only native felid remaining on the landscape here. And it's not just Appalachia, it's the whole eastern United States with the exception of southern Florida from the Midwest over. And I think that there's a couple ways to look at this, but I think one way to look at it is they're a native field species remaining on the landscape. They're a charismatic species. They're widely recognized by the public. And I think that, they're a really good tool for communicating these ecosystem scale topics, like this forest issues that we're talking about that go way beyond single species management. I think that they could be a really useful tool for engendering public support for these management practices like fire and timber harvest, where the general public, where they're not educated, might be against things, especially timber harvest. But this is a way to communicate that to people. And we already messed up the bear because we had Smokey the bear, and he told you not to set stuff on fire. So we should probably just forget about that for a little bit. And maybe this bobcat would be like a better vessel in which to communicate this message. But more importantly, I just would like to see research in this region continue on bobcats. They're back on the landscape. They're not just here. They're in the coastal plain. They're in the Piedmont. So it was really cool. We were able to take, data from this broader study and learn about bobcats. But the sample size is fairly small. And it would be cool to see more research done in Virginia and neighboring states that are looking more specifically at bobcats and their ecology throughout their distribution in the region. So with that, I've got a ton of people to thank. I'm part of this bigger study, so I can't take credit for much other than just the part that I played in it, and there were a lot of people involved. First of all, I need to thank Virginia Department of Game and Inland Fisheries for funding this whole study. And Mike Fees, the state fur bearer biologist, is really the architect behind it and pushing to make it happen and get this research funded and get it done. So a big thanks to Mike Fees for that. But beyond that, when me and Robert are in the field and we end up homeless in the field or the trucks break down or whatever happens, Mike is always there to figure out what he can do and get us help. I mean, we're driving trap lines every day. We got trucks breaking down all the time, and he's just there to help us keep them on the road. Big thanks to my committee. Mike Cherry's helped me a ton with designing all this analysis and so forth. Big thanks to everyone else that has collaborated and supported this study in the field or on any level. The Nature Conservancy and the Forest Service have supported us a ton and collaborated with us on every level, from study design to field work to data analysis, supplying the data. They've helped us a ton. And to all my former lab mates, the lab I came in with is almost all gone now, because I've been working on this degree for so long. And I've got a whole new lab now, and they're all awesome. And I've made a ton of lifelong friends in this department. I've been getting texts and emails for the past 3 days, people wishing me luck from the field. So, just so many great people. I've had nothing but positive experiences. And thanks to the Bobcats, because they were not always happy to see me. I can promise you that. But it will benefit them in the end. They just can't understand that. And I got to take a minute to thank a couple people in particular and acknowledge them. The first one being Marcella. As she mentioned, I first came to work with her in 2013, and I've spent basically the bulk of my 20s working with Marcella, my whole career basically. Yeah, so time to go off and do some other stuff for a little bit, But yeah, so I was looking back for photos from 2013, and a lot of great photos. But I think this one here on my 22nd birthday really sums up what I like the most about Marcella and why I've stuck with her. And at that time, I'd only been there for about a week. I barely knew her. I was a technician. I had just transferred from culinary arts, so I didn't know anything about wildlife at that time. And I thought, I'm here. My role is to sit in the back of the truck, shut up, and do my job. And, I'm a technician. Maybe make some mango salsa or whatever. I guess that helped. But I mentioned maybe once in passing that I had a birthday coming up, and there were a whole team of people there. And on my birthday, Marcella drove us all to this really nice eco lodge and had them make me this cake and surprise me with it. And I was, just a technician, so it's that's what I like most about her, is whether you're an undergrad or maybe you're even thinking about getting in the field and you walk into her office, or you're some big wig researcher with a huge ego, she's going to treat you the same either way. She doesn't treat anybody as lesser. She treats everybody equally, and she treats everybody with the same respect. And that's a big reason why I've stuck with her for all these years. And then also, Robert, I didn't even mention it, but we also caught 50 bears and a bunch of coyotes on this study, and me and Robert have been through a lot over the past few years, and I've gained like a best friend in Robert, but also, normally it was just the two of us up there in the field and catching these 3 species, just the two of us. So trapping 7 days a week, 14 or more hours a day from winter all the way into summer. And it's not the times catching the animals that I remember, it's the times when we weren't catching the animals that I think were the most important. The days or maybe weeks where we're not catching any coyotes and they're busting our traps and we're grinding double hard to get it done, or we're dragging dead deer carcasses up a mountainside, or whatever it may be. Like, I grew a ton and I learned a lot by going through these experiences with Robert and us navigating them together, and then also learning from his experience and the way that he navigated situations. And then most of all, I got to thank my family, because like, obviously they brought me into the world and stuff. They also, have been incredibly supportive throughout this process. They've, helped me navigate tough situations. They've visited me in the field, talked me through the tough times and stuff. So yeah, thanks to everybody. And I'm sorry if I didn't mention anybody, but there's just so many people involved in this study that I can't thank everybody enough. And with that, I'm happy to take any questions about the research.
So like kind of throughout the whole talk, which was really good.
Thank you.
I was interested in like the sex ratios that you had captured, and that you caught. You said you caught 7 males,
Yeah.
3 females, both years. And then in your conclusion, you said something about like you want to know like what's going on with sex ratio. So do you think that there actually are like, is there any like literature or just like any insights that you have? Are there actually more males on the landscape than females?
Well, so yeah. Sorry, are you done?
Yeah.
So sorry, I didn't want to cut you off. So I think that comes back to the space use of males, that they're moving more on the landscape. And generally, when you're doing any type of trapping, whether it be camera trapping, jaguars, or trapping, you'll often get this male bias. It seems that males are generally more likely to use roads and trails. Females, especially if they have kittens with them, might not be using these areas. So there are a lot of factors involved in that. I don't think there are more males than females on the landscape because they use more space and they're territorial. But if anything, it's probably equal, would be my guess, or maybe female skewed. But also important to note is we did have to turn some females loose, just because some of the females were so small. Some of them were juveniles, but we couldn't safely put a collar on them. So we actually caught 23 bobcats. 2 or 3 of those were females we had to turn loose. Yeah.
Very nice talk, and I particularly like the historical business in the beginning.
Thank you.
So I have a question about the elevation. There's a host of environmental correlates that go with that: vegetation density, species composition, moisture, distance from roads and people, and all that. And you mentioned at one point, you just mentioned in passing kind of, but so maybe it was risk avoidance or something being up there. Could you expand on that a little bit? What is it about those ridge tops?
The ridge tops? Well, I think in Appalachia, you have a especially here, this ridge and valley region we're in. It's systematic topography. You've got the ridges and the valleys running a long way. And I think that, the ridges are almost always public land in this area, generally speaking. That's not always the case. The valleys are generally private land. The valleys are where you find development, and it's typically lower intensity development, cattle ranching, and some exceptions like here, but generally it's low intensity development. But I would venture to say that in this, this historical forest that I'm kind of outlining, that bobcats would have selected for the valley bottoms, that is where those riparian areas were the richest in prey, probably the densest cover, and that the ridge tops were generally, not as quality habitat. And I think that this is probably a trend that's been caused by the land use patterns of the landscape. So in short, that's what I think is driving that pattern. Heather, and then Marcella.
First of all, nice job. I have
Thank you.
2 questions.
Okay.
So the first, is related to your methods. Did you look to see how the size of core use areas change among seasons?
I did look at core use areas, and I didn't detect any changes in core use areas, but I am hesitant to highly trust the core use data due to the poor fixed success in some of the collars. And looking at a utilization distribution, I wouldn't necessarily put all my stock in those core areas. Unfortunately, that's, the nature of the data. But I did look at that. I didn't see any seasonal changes in those.
And then the second question is, why do you think that movement rates for males were lower in the breeding season, or that they weren't significantly higher?
Yeah. So technically not significantly lower, but yeah, and their home ranges weren't. Yeah, their home ranges were not significantly different during the breeding season, but you might have noticed there's more variation there, and the mean was higher.
Oh, sorry, I was talking about movement rates.
Yeah, I'm saying both though. So we saw actually there were some differences in home range size then too. They appear to be, for some of them, a little bigger. I shouldn't say that because it's not significant, but yeah, I think that I think this comes back to the breeding behavior and the cost of breeding behavior. I think that they're on these steeper slopes. We know that they're selecting for steeper slopes during this time, and that in itself is higher cost of locomotion. It's just not conducive to moving further throughout the landscape. But I mean, I know the way that a lot of felids breed is they will copulate repeatedly. I think that we need to really pay some attention to that breeding behavior that's taking place during that time. Not just the marking of territories and the territoriality, but the actual breeding that's taking place then. It's probably a lot of work breeding all those females. Not a lot of time to run all over the place. That's what I think. Yeah. Marcelo?
And in regards to prescribed burning, did you have any opportunity to look at if a burn occurred over the landscape, look at the collars out, just a pre-burn home range versus a post-burn to see if it starts engulfing maybe an area that wasn't?
Yeah, that's a really good question, and I was really, really hoping to, because that big 3,000 acre burn they just did is right in the heart of our study area. We had collared bobcats there, but this kind of illuminates some of the issues with burning. Is every year for our whole field season, they were supposed to burn that unit, and every year they would get close and tell us they're going to do it and then have to call it off because there are so many things that need to fall into place. They need a lot of boots on the ground, which is just hard, to do in itself. But the weather window needs to be perfect for smoke, for the burning conditions. So it just didn't end up happening, unfortunately. They burned it all right after I was done. So, yeah. Ashley?
Great talk. I'm interested in your small sample size and what implications you think it might have for your findings. Are there certain parts of your findings that you're less confident about given that sample size, or things that you might think you see big differences if you have a larger sample size?
That is a great question, and I would say I'm confident in the male data because, as I mentioned, for bobcats, that's pretty good. I mean, it's not amazing, but relatively speaking. But yeah, my confidence is not very high in the female findings. I think that's where we just need to rely on best available science. But I really would advocate for further research. I would advocate for a bobcat study that would collar a bunch of females and males, but also in the Piedmont and in other parts of the state. I mean, I understand that'd be really expensive, but Mike Fees, I think you should make that happen.
I know you couldn't really look at this in your study, but how much do you think other predators affect their spatial use? Maybe most coyotes than bears. But.
Yeah, so I didn't really have time to touch on that, but that comes to some of the seasonal differences that I saw. And one thing is that bears are not on the landscape half of the year, and that makes for a very interesting community. And during these summer months, you have a lot of fawns around field edges. We don't know to what degree fawn predation is occurring, but that's a pulsed food resource on the landscape. And if you're a carnivore, that's something you're going to want to capitalize on. Coyotes are known they have been observed killing bobcat kittens before. So I think that for females, and I don't remember if I mentioned, I didn't get deep into the seasonal changes for the sake of time, but that females were further into the forest during denning season, further from fields too. And I think that might be some kind of niche partitioning where you have literally all the competitors probably focused along those field edges. I would think. I don't have the data to back that up, but I think it could be partially avoidance to avoid predation of kittens. and potentially also just they need to acquire a lot of prey fast during that time. So it might be easier for them to partition to a different area, maybe consume smaller prey during that time, and maybe squirrels or something like that. I don't think it's as much of an issue for male bobcats because we've got some camera data. We put carcasses out, put cameras, and male bobcats, or just bobcats in general, they're pretty scrappy. So I think that, you know, they'll feed on carcasses when a bear is nearby. They're not going to be really impacted to a huge degree, but I think to some degree it might influence it. As I mentioned, I can't say with these females that I'm 100% confident on what's going on there, but I do think that it plays a role. I do think so.
So I was interested in your movement data when you talked about looking at the distance between steps. How often were your GPS recorders taking points, and how much problem when you said you had some low quality fixes?
Yeah.
How often do you get problems with those gaps?
Yeah, that's a great question because obviously when you're looking at a 4-hour time interval, you're not looking at speed. You're looking at more coarsely a movement rate. So what we don't have as fine scale of data to actually mimic their movement behavior exactly. And there's a ton of literature behind that. I didn't mention it, but I only used 4-hour fixes in that. So I discarded anything that had a longer interval due to a missed fix. Now that being said, the research that has been done in this region, there was a study in Kentucky, there was a study in Tennessee in the 80s and in the 70s. They were using VHF telemetry, and at best they had 1 fix a day. So their movement metric was daily distance moved. So I would say we're doing better than that, and the battery limitations of bobcat collars make it that we can't run a 15-minute interval or something like that. So we just have to work with what we have. I believe 30 meters.
So you feel like you missed over some really small openings because of that, I guess?
Yeah.
And is that an issue, do you think, or do you think you missed places?
I don't think so because generally when there are openings in the forest, at least up there on those lands that are mostly public, it's due to the timber harvest or the fire. And I had that data to use concurrently. But I would certainly say that some could be missed. But I would also say that, you know, due to the error of GPS collars, that's probably the relevant scale that we can really examine anyways, because they could have 30-meter error in the GPS collars. So it's possible, but I think we accounted for the canopy openings the best we could and captured it fairly well. Not really. I mean, some of them ran for 14 months, so a little bit longer than a year. And we actually just had, Robert was coyote trapping this past spring, and he put a new collar on a bobcat that I had collared last year. So we will have 2 years of data for that one. But that's just one individual, and yeah, and I'm done. So no, I'm just kidding. Sorry? Yeah, that's very interesting because actually Dr. Mike Connor down in Georgia has published a paper looking at time in residence and the influence on home range size. And it does appear that the time that a bobcat is a resident can affect their home range size. I believe that male home ranges will get larger and female home ranges will get smaller. And he attributed the female home ranges getting smaller to like spatial learning of their environment and being able to utilize resources in a smaller area with less cost of movement. So there is evidence for that. Unfortunately, it's very hard to get concurrent years of data for bobcats with GPS collars and their relatively short battery life.
I've got a question about the potential for human disturbance on either home range size, movements, resource selection. Knowing Bath County is a huge influx of hunters, you get roads being opened seasonally. You've got hounds on the ground down there for bear hunters.
Yeah.
You've got the homestead, which gets a lot of seasonal use at times. Any inkling or any, can you give us anything about what that may mean to your results that you've seen?
Yeah, I can speak to it anecdotally. wasn't able to analyze development in the true sense of development on the landscape due to the spatial organization of it. It's all mostly in that hot springs area. And then also the pump storage station and Gatherite Dam, they're classified as disturbance too, and they kind of vary widely in how they actually are, disturbed, so to speak. So I didn't model disturbance, but anecdotally I can say that we have one male bobcat. Did I have this slide in here? Yeah, so that bobcat there was taking out someone's window. He's been hanging out in Mitchelltown, north of Hot Springs, a lot, and he's being seen all the time, and he seems to have no problem using it. We've seen other bobcats too use development quite regularly. Mostly males we're seeing using the development, but females will make occasional forays into the developed areas as well. And there's tons of research showing that bobcats can thrive in development in some areas. Like there's a recent study out of Dallas where they estimated almost one bobcat per square kilometer, which is the highest densities I believe that's ever been estimated. Same in Southern California. So we're seeing some use of that. As far as hunters, that is, kind of hard to tease out because there is certainly some hunting up there on public lands. It's generally mostly focused around the firearm season and the bear chase season. And the landscape is broad enough and the distribution of hunters probably not concentrated enough that for the range of a bobcat, they can probably avoid it. Now, these increased movement rates that I saw during the dispersal season, they could be attributed to that. It's possible that that those higher movement rates are caused by disturbance on the landscape during that time. That's been proposed before. A study in Mississippi found that. But due to the size of the home range and the landscape, I think they could easily avoid that. And then also the hound chase season for bobcats continues into the breeding season. And the bobcat chase season, those people are running dogs when there's snow on the ground generally for bobcats. So that's January and February. And, we actually saw lower movement rates during the breeding season. And there aren't a lot of people that do it, but some do. So, I can't speak to it in a concrete manner. I can say that bobcats are using development to an extent. They don't seem to be scared of development or avoiding it largely. And as far as the hunters thing, I can't confidently speak to that with the data that I have.
Okay, we've got to ask him some more questions.